Okay, good morning. I'm going to go over a couple of the questions from the linear functions test. I actually made it so that you guys should be able to see the correct answers on that test now. But we're going to go over slope from a graph, slope from a table, writing linear equations, that kind of thing. So you can watch this video at your leisure. So number one asks you to find the slope m of the linear functions represented in the graph. Now I know a lot of the questions said, if they're asking for m, your answer should be m equal, asking for b, which is the y-intercept, it should be equal. It literally tells you right here in the question which one you need to find. So let's go to the show your show your work section. Okay, when you're finding this for a graph, you're going to pick 2 points that are on the crossroads. Where all of these gray lines meet, these are crossroads. Like this is a crossroad, this is a crossroad. They've actually given you, or I've actually given you, those points already in this line. So you're just picking 2 of them. You can pick this one and this one. You can pick this one and this one. It doesn't really matter. When you're looking, the first thing you should think of is which way going left to right am I going? Am I going uphill, which would mean positive slope, downhill, such as this line, which would mean negative slope? Am I walking on a flat surface, which would be 0? Or am I trying to fly, which would be undefined? So I'm going downhill. This is going to be negative slope. And what I want to do is draw my slope triangle. So I'm going to use this point and this point. And I can see it's kind of like these are the roads, and how do I get there on the road? I'm going down 1, 2, 3, 4. And I drew it a little bit longer than what needed to be done here. So just ignore that little bottom part, and I'm going over 1, 2, 3, 4, 5, 6, 7, 8. So remember, your slope is the change in y, or what's changing up and down on the graph, versus the change in x. So we can see up and down, the distance between these 2 points is 4 units. And because I'm going downhill, it's a -4. And side to side, the distance between this point and this point is 8 units. And I'm moving to the right, so that's positive. And then I look and see, can I simplify this? In other words, is there a common factor between 4 and 8? And there is, because 4 can go into both. Well, 4 is going to go into itself once. I'm going to bring that negative over. And 4 goes into 8, or in other words, 8 divided by 4 is 2. So my final answer should be -1/2. Now, say you had chosen this point and this point. I'd go down 1, 2, 3, 4, 5, 6, 7. And over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'd wind up with -7 over 14 and -7 over 14 would still simplify to be -1/2. So it doesn't matter which points that I choose, I should still come up with the correct answer. Now say we forgot to look at it as going down, and say we built our triangle backwards. Well, if we're going from here to here, we're going to the left. So that would have made this a negative and this a positive, still leading to -1/2. If you don't like drawing the triangles, you can just determine 2 points. This point right here is 0, 1, 2, 3, 4, 5. So 0, 5. And this point here is -8, +9. And you can approach this as what is the slope between 2 points using the slope formula. And we're going to get into slope formula with one of the other problems coming up. Let's go ahead and move on. Okay, number 2, we're not going to do, but we should see this is going uphill, so this is going to be positive slope. Number 3, they're asking you, can you fly? No, you cannot. This is undefined. Number 4, flat line, flat ground, slope should be 0. Okay, number 5, finding it from a table. So 2 choices for the table. We could either expand the table, and we're looking for the value of y when x is 0. Or I'm sorry, we're just finding the slope here. So when we're finding the slope, again, it's still the change in y over change in x. And one of the things that always confuses kids is the y here is on top, the y here is on the bottom. Basically, just need to flip it. So change in y, I can pick any 2 points to go from 8 to 2. When I'm thinking of this, I'm thinking of a number line. And I can see that if I'm at 8 and I need to go back to the number 2, first off, I'm moving to the left, which means it's going to be negative. So 8, 7, 6, 5, 4, 3, and 2. In other words, I moved 1, 2, 3, 4, 5, 6 units backwards, or negative 6 units. And for the x, I went from negative 6 to negative 2. Again, I'm looking at a number line, and if I'm at negative 6 and I'm going to negative 2, I'm going to the right, which makes it positive. So negative 6, negative 5, negative 4, negative 3, negative 2. So 1, 2, 3, 4 units. And then change in y over change in x. You found the change in y to be negative 6. And you found the change in x to be 4. And just like when we talked about doing it with a graph, I look to see if there's a common factor. Is there a number that goes into both? In this case, it's 2. 2 goes into 6 3 times. I'm going to bring over that negative with it. And 2 goes into 4 2 times. So my final answer is negative 3/2. And just like before, it doesn't matter which ones you picked. If you picked a negative 7 and negative 10, you would have saw you went down by 3 here. From 4 to 6, you went up by 2. So no matter which 2 sets you choose in a table, but they should be next to each other to make your life easier, right? You should get that same value. I mean, you could go from 8 to negative 10, but you make a greater opportunity for you to make an error in your arithmetic. So it's how we do it with the table. Also, when you're thinking here, as long as x is going in order, meaning from least to greatest, when you're looking at your change in the y, if that's going down, right, if the numbers are decreasing, it's going to be a negative slope. If they're increasing, it should be a positive slope. Now, what happens when you're looking at a table and your y never changes at all? If your y never changes, your answer is going to be, well, like if you're doing that as an equation, you'd have y equal to a number, so that means you're going to have a 0 slope. And if your x never changes, that's where you're flying, and that's going to be undefined. So that's finding slope from a table. Okay, 2 points. 2 points, we want to use the slope formula. We should know m equals y of the second point minus y of the first point over x of the second point minus x of the first point. And it doesn't matter which ones you decide as 0.1s, which ones you decide is 0.2. Because y2 and x2 come first, I usually just use the first point for that, but you could do whichever you want. If you're struggling with this, I would say label your stuff. So we're going to use this as x2, this is y2, x1, or x of the first point, x of the second point, I'm sorry, y of the first point. So let's go ahead and put this information in here. So I'm going to take both of these and put them where they need to go. So m equals y2, which is 14, and its matching x needs to go right underneath it. So x2 is -7. Then I'm going to subtract, and take my second point, and again, kind of flip it in my head so it's -4 on top, 2 on the bottom. Now when I have a subtracting a negative, right, I'm going to do a change here. So I'm going to change the subtraction to addition, and I'm going to flip the sign of what's after it. So this is going to become 14 plus, and this negative will also change to a plus, so it'll be 14 plus 4. And on the bottom, I'm going to change this subtraction to an addition, and this +2 is going to become a -2. So 14 plus 4, 18. -7 and -2, same sign, add, keep the sign, -9. 18 divided by -9 is -2. Okay, so my slope is a -2. Okay, the great thing about the slope formula is you can really use it for any of the answers. The one we just did beforehand with the table, you could have just chosen 2 points out of the table and used that 2 points information here in the slope formula. You can grab 2 points of a graph, put it in the slope formula. So slope formula is kind of like the ultimate place of where we want to be, is basically doing it just algebraically. Okay, looking at this one here where it's giving us an equation and it's asking us to find the slope. By this point, I hope we know when we know y equals what. We say y equals mx plus b. So we're literally looking for what is the coefficient, or what is the number in front of x. If we don't see one there, we know it's some type of 1, right? If it's a negative x, it's a -1. If it's a positive x, it's a +1. But in this case, your m, or your number right in front of x, is right here, and your answer should be -5/4. So there's no additional math to be done there. It was literally just recognizing it from the equation. Now, you need to make sure the equation is in the same form, and it is y equals an m, an x, and a b. Okay, let's move on and do y-intercept. So on a graph, your y-intercept is literally wherever your line crosses over your y-axis at. So we need to remember, in the morning, we're lying down, so x. Before we stand up, y. Then I literally look and see where this y-axis and my graph intersect. And I can see that it's right here. So the location of that point, or the coordinate point, is 0, -4. Now when you're finding an intercept, you want, if they say the y-intercept, they're telling you they want the value of the y. They want the x-intercept, in other words, where does this cross over the x-axis at, which would be right here. They'd want the value of the x. So in this case, RB, or y-intercept, you can say is -4, where the graph crosses over. Okay, on a table, this is where we're going to have to either do table expansion, or we're going to have to do the B method. But in either way, we need to find the slope of the table first. So again, I'm going to find the change in y. This is -6. It's actually the same table that we did beforehand. And this is a +4. So our slope was -6/4. In other words, -3/2. So this tells me two different scenarios. This tells me every time x moves 2, y goes down a -3. Or as a whole, it tells me every time x moves 1, y goes down 1.5. Okay? So I can use that to help expand my table. I need to get back to where x is 0. Okay? I need to get back where x is 0. And find the value of y at that location. So first off, I'm going to find out from this x all the way back here, how far am I going? How far am I going backwards, right? So remember, this is going forwards. Every time x goes forward 2, y goes down a -3. So the opposite of that is when x goes back 2, y is going to go up a +3. Because remember, 8, 2, -7, 10. These numbers are decreasing. So if I'm going backwards, those numbers have to be increasing for the y. So first I'm going to see how many x's back I go. So from -6 all the way back to 0, I'm moving 6 units back. Okay? Now keep in mind, when I look over here, that change in x is a positive. The fact that the change in x here is a negative is telling me I'm moving backwards. So how many 2's go into 6? That would be 3 moves of 2. Okay? Which means I can do 3 moves of the y. So -3 times 3 would be -9, but I'm going the back way, so it has to be positive. I'd have to add 9 here. And 8 plus 9 would be 17. Now, of course, if that math is too much for you, you could literally add in all of the spaces in between. And usually if you're going up by 2, I would go back by 2. So on your table expansion, you can go, I'm going to find that 0, and I'm going to find, here's the last place we were at, -6 and 8. And to get back to 0, actually, to get back to 0, right, is actually right in between here. So actually, ignore what I said beforehand. Haven't had all my caffeine yet in the morning. So right in between here is where we want to do that table expansion. So -2, 2, 0. And then imagine we'd have 2 and 4. Now we already know our slope is -3/2. Sorry about that, I wasn't completely awake. So going forward, every time x moves 2, y is going to move a -3. So we could see here, that was a double move, right? To go from -6 to -2, that was a +4. That was a double move. That was 2 2s. So therefore, this went down 2 y's, 6. From here to here, we're only going over the 2, which means this should have to go down to 3. -2 minus 3 would be a -1. So our B would be -1. Now your other choice is to do the B method. Okay, we're going to do that now. So in the B method, we still find our slope, change in y over change in x, which we found out to be was -3/2. And then we choose one of these points. It doesn't matter which one we use. I like using ones that are all positive, so I'm going to use 6 and 10. So the point 6 and 10 is x value of 6, y value of 10. And I'm going to use the formula that I know, y equals mx plus b. Keep in mind, each one of these points is a solution to the equation that you would write to represent this. Now we're trying to find a piece of that equation. We're trying to find the y-intercept, right, the b. But because these are solutions to it, we can use a solution and m, and that should lead us to the correct b. So in this case, our y that we're using is 10. Our m is -3/2. Our x is 6. And we're trying to find b. So we do the math. -3/2 times 6. So -3 times 6 is -18. And -18 divided by 2 would be -9. And then we just isolate b. We add 9 to both sides. And we get 19 equals b. Feel like I'm missing something here. Because it should be what? It should be a -1, right? Because we said we did the table expansion. If we were at -2, 2. Oh, I'm sorry. That's why that's -10. Missed the negative there on the table. That's a -10. So it would be a -1. Knew I was missing something somewhere. See, even Miss Egan makes mistakes. That's why it's like you got to think through what you're doing. Would 19 have fit in between the 2 and the -7? No, that wouldn't have made sense because it's linear. My numbers got to go in order, least to greatest or greatest to least on the y side. So again, my answer is -1. Okay, the third one, we have to find b given 2 points. So we're going to use that b method that we just talked about. So first we're going to find the slope. So m equals 14 over -7 minus -4 minus 2. Wind up with that 18 over -9, and our answer winds up to be -2. This is the same one that we did beforehand, right? So we know our m is -2. And we're going to choose one of these points. Neither one of them are both positive, so I'm going to pick the smaller numbers. And I'm going to substitute that into y equals mx plus b. So -4 equals -2 times 2 plus b. So -4 equals -4 plus b. When I add 4 to both sides, I'm going to get 0 for b. And that's okay. It's okay to have a 0 at b. Remember, that's a direct variation. It means it's going through the origin, right? So my b would equal 0. That's how you do it from 2 points. From a table, we should know y equals mx plus b. So y equals mx plus b. The b in this case is 7, right? We're just literally, we don't have to do any math on that one when we're given the equation. We're just finding it. Write the equation of the line. The equation of the line, you're doing the same thing, the same two things we just did. You're just putting them together. So when I'm looking at this line, I'm going to first find my slope. I should tell it's going uphill. So it's going to be a positive slope. From 5 up to 10 is me going up by 5. And over 5, so up 5, over 5, my m equals 1. And I cross over right here, which is b equals 5, right? So I just did the slope and I found the y-intercept. I got to do those two things. Those are the two pieces of information you need. So y equals 1x, positive 5. I don't need the 1 in front of the x, so I just put y equals x plus 5. From the table, you're going to do the same thing. You're going to find the two pieces like we did beforehand and write the equation. For steepness, number 18, it says put the following linear equations in order of steepness. Well, first thing you need to do is you need to find the slope. Slope measures the steepness, so find the slope of each one. And the rule is, imagine a number line. 0, remember, is a flat line. So the further away it is from 0 on either side, the steeper it is. So for example, a 2 is steeper than a -1. But a 2 versus a -4, the -4 is steeper because it's more units or further units away from 0 than the +2 is. So first thing, find the slope. Then, kind of ignoring the signs, put them in order of the largest number to the smallest number. Categorize each representation as a direct variation or not a direct variation. Remember, a direct variation goes through the origin, right? Goes through the origin. So how do we measure that? That's about finding the y-intercept or finding the b. So when I look here, this one, if it's going through 0, 0, which it does not look like it is, so this is a no. This one, it doesn't have a b, meaning the b is 0. This is a yes. Through the origin, yes. Here, I'd have to find the b. So I'm going to have to find the slope and then find the b, right? Or do that table expansion to find out, is it 0, 0? Looking at these numbers, 16, 8, -12, -20. Well, to go from -2 to 0, that's going to be 2 moves. It looks like every time x moves 2, y goes down 8. So this is going to be a yes. Here, every time x goes up 2, y goes down 8. So 2, 8, that would wind up being at a -2, so this is a no. And here, b is 1, so this is a no. The x-intercept. Remember, the x-intercept is the value of x when y is 0. So when I'm looking at this, literally what I'm doing is I'm going to cancel that out, and I'm going to be left with 5y equals negative 30. And I'm therefore going to solve that equation. Divide both sides by 5, and I'm going to get y equals, sorry, not y. These are the x, sorry. I'm going to get x equals negative 6. Finding the y-intercept of this one, I'm going to get rid of this part, and I'm going to have negative 6y equals negative 30. If I divide both sides by negative 6, I'm going to get y equals 5. Do it again, make it clean. So I'm finding the x. This is gone. 4x equals 12. Divide both sides by 4. X has to equal 3. Here, I'm getting rid of that, and I wind up with 8y equals 12. Divide both sides by 8, and I'm going to get y equals 12 over 8, which should simplify to be 3 over 2 because 4 goes into both of them, right? And that concludes going over the test on linear functions. Hopefully this helps you get ready for the retest.